My name is Dr. James Rudich, and I'm an internal medicine physician. I specialize in infectious diseases and management of patients with HIV infection here at University of Michigan. The project that we're working on involves the development of a device that can be used in resource-poor settings where measurement of CD4 cells can only be done through a bulky machine that requires specialized laboratory conditions, specialized reagents, etc., where the specimens need to be transported to a remote location. Antiretroviral therapy is the key to prolonging life in patients with HIV infection. There is a limited amount of antiretroviral therapy available because of cost constraints in the developing world. And this device will allow us to select people who are most appropriate for that treatment and also help to monitor them while they're on treatment.
My name is Anurag Tripathi and I'm a PhD student who has been working on this project for close to 5 years now. So what we decided was that if we have to make this chip cost effective, we need to have a method by which we can create thousands of chips on a single substrate. So the process we employ for the fabrication of this device is standard silicon microfabrication, in which we take a silicon substrate, spin a layer of polymer onto that, and by exposing it through a photomask, we transfer the pattern onto that UV curable polymer, develop that in a solvent, and at the end of that we have a mold with the patterns onto it. Now subsequent all the processing steps, they take place in our lab, where we take that mold, pour another curable polymer onto that, and when we peel that polymer off, we effectively get the pattern transferred onto that polymer, and that's the polymer which forms the crux of our biochip. This device consists of about 10,000 micro holes which act as filters. So when you pass a blood sample through it, they squeeze out most of the blood cells, the red blood cells and the platelets, and the bigger white blood cells, they are captured on this device. With one snapshot using this microscope, we are able to count thousands of them.
Our ultimate goal is to develop a device that requires just a pinprick with a drop of blood administered into the biochip. The chip could then process the specimen automatically and be inserted into a device that would then read the CD4 cell counts. The importance of this project is to bring point-of-care, inexpensive testing to remote areas so that the most people can benefit from antiretroviral therapy in the developing world in an optimal way.